Well, good morning. Thank you very much. My name's John Shenton, and I'm chair of the Dubai Hub for the Chartered Institute of Building. We're the largest professional body internationally for the practice of construction management. Now, our members are typically involved with implementing digitization during the build process. This panel discussion is looking at enhancing operational efficiency with technology. So after the build process is finished, once we've constructed the asset and it's operational. I'd like to invite the panelists to introduce themselves, so in no particular order.
Thank you. Good afternoon, everyone. My name is Yasser Ahmad. I look after the digital buildings business in Schneider Electric Middle East and Africa. That's a business concerned with all technologies around BMS, around IT, around sensing, artificial intelligence, cloud, and a lot of keywords that we have been hearing across the day so far. Another mandate I have is looking after the synergy of the software companies we have acquired in the past 2-3 years, also related to building digitization. Very pleased to be with you and with our esteemed panelists today. Thank you so much.
Hi, everyone. This is Walid Shraim from JLL. I'm representing the team of BNDES Project and Development Services, specifically considerations of energy and sustainability team. We are working with our clients on advising on energy and sustainability aspects for the asset management, for the facility management, for design and project delivery services, as well as developing strategies and implementation for the energy and sustainability strategies and targets that our clients are having. So we deal on a daily basis with clients to resolve issues related to embodied carbon and reducing carbon emissions, as well as combating climate change. Very pleased to be with you today.
Hi, my name is Rohan. I head up the Smart Cities and Smart Buildings division at AESG. Part of what we do is provide design and implementation strategies for smart buildings, really getting stakeholders to understand exactly what a smart building is in the first place, and provide certification services on smart buildings as well.
Thanks, Rohan. Hi, I'm Prem Anand. For a company called Zoho. Over a decade of experience and take care of multiple departments to touch upon. I head the strategic alliances and strategic planning team, and also taking care of solutions consulting for Middle East and Africa. Thank you.
Hi, I'm Debashish. I head a company called Pinnacle Infotech, which is basically a BIM and digital twin implementing company. I head the Middle East and Indian operations, and I'm glad to be here, honored to be in this distinguished panel and with audience like you. Thank you. Looking forward to the session.
Fantastic. Now that we've done introductions, gentlemen, if we explore the technologies that all new buildings should look at, if we've got a smart building, I suppose, Yasin, what sort of technologies should owners and operators be looking to explore?
That's a very interesting question, John. In fact, smartness can be explained in very different ways. Yeah, some people would say a smart building is a building that is very connected to the occupants who are around it and can get engaged with all the assets around them. So this is one area that can describe a smart building. Another area that can describe a smart building is that building is very aware around of the resources and the energy and the spaces, how it is consumed, how it is utilized. One would think that smart building is a building that is very interactive with the grid, how the building is behaving in response to the different changing environment around the energy and around water and around the resources around it, how the building is connected to the grid. For me, I think the three aspects are very interconnected. The smart building is a building that can respond to the people, the occupants, with a very seamless experience and a very healthy experience. A smart building is also a building that is very aware around the energy and resources. A smart building is also a building that is very flexible in the way it interacts with the grid and interacts with the supply it comes to the building and the consumption of these resources inside the building. For me, this is what defines the smart building.
Fascinating.
Yeah, and right. So basically, one of the things that we've been working with on a daily basis, and coming from energy and sustainability point of view, is basically, and looking at that everyone's eyes now is on COP28 and what would be the outcome of COP28 in terms of how governments, companies, and corporates will have to deal with their targeted reductions in carbon emissions as well as fighting the climate change. Everyone has a target now to reduce carbon emissions. Carbon emissions means energy, means water, means embedded carbon, means operational carbon. So how to address all of these aspects? Built environment is contributing to almost 40 to 45% of the primary energy that we are using globally. Now, 80 to 90% of that is being consumed during the operational phase of the projects. So FM teams have a huge responsibility to deal with this on a daily basis. Now, looking at what is currently being done is that we have to understand that facility management, as well as the contractors who are considering works related to embedded carbon and the construction activities that we have during construction stage, together they need to consider how they can improve in terms of what kind of technologies that they need to utilize to address these kind of topics. Now, we know that smart buildings means that a building that should be adapting to people and should be interacting with people to respond to people behaviors and basically being more sensible. So how to make a building more sensible? We know the struggle for FM teams that they are having an issue with, for example, improving the efficiency of their buildings on annual basis. They have KPIs to reduce the energy emissions on daily basis, on annual basis, but also they have limited budgets to do retrofits. So what can we do in this regard? Do we have any assets, existing assets within our buildings that will help us do improvements in energy efficiency without paying an arm for it? The answer is yes. We have nowadays design of buildings that is surrounded around the connectivity of buildings. We have networks in almost each and every commercial building in the market. So there is no single hospital or office building or educational facility or a hotel that doesn't have a Wi-Fi. Simply, Wi-Fi can be a solution of many topics that we have. The data that we get from Wi-Fi tells us when people are coming in, when people are leaving, how busy a space is at a specific point of time. This data for regular visitors as well as the occupants of these buildings will enable us to control building systems in a much better way. So the integration between building controls as well as the IoT is the key for this, I believe.
Fascinating. If we just got over here, on an app side of things, in terms of the Internet of Things, how do you bring those different aspects together?
Sure. I think I'll take a step back and when we talk about any kind of construction or project management, right? It might be old or new buildings. I think we have to talk about the project management aspects of it. The word project management seems to be very casual. Because every day we hear about project management in all kind of business. But especially when it comes to smart buildings and constructions and over this side, I think it plays a very major and a key part about it, because in the recent times we had an encounter of one of the biggest construction company over here, wherein they called us on a piece of advice in terms of how we can efficiently manage the project by integrating with all the other aspects of it. I think that is one of the key things wherein we realized that a few companies in terms of tech, they wanted to accelerate their efforts in terms of one software which is going to talk to the other softwares to get the data and then basically handle everything from one single aspect. Because it might be an owner or a constructor or somebody from the office, they just want to open the application and see, okay, where my project is, what's happening to the project, what is the budget, what is the plan, where are we right now? And for that, we have to make multiple WhatsApp conversations and calls and talk to multiple people. But if we have one single software, I think it solves the majority of the problems.
Rowan, I can see you nodding your head in agreement there.
I would like to tackle this question slightly differently. I think a smart building is not about the what, it's about the who it's serving. I think it's a building that sort of achieves a set of outcomes, and those outcomes need to be defined by use cases. Those use cases and outcomes are then underpinned by technology. I think the mistake that we make in this industry is sort of jumping straight to tech without actually thinking about the layers and mapping out those layers from that device to the end user. So really define those outcomes, and like Yasser touched on, that could be in terms of realizing a financial result through cost efficiencies, or participating in sort of a city ecosystem and meeting high standards of sustainability. Whatever those outcomes are, they need to be defined, develop use cases, and then design the technology that supports that.
Fantastic. If we move the discussion on a little bit, we're about 65 days out now from the start of COP28, where the international community will try to find some degree of leadership to agree the measures to move us towards a net zero future. If we were looking at digital twins, will they become a prerequisite for a net zero building? Debashish, I'd like to see your thoughts on this one.
Yes. So I'll try to, it's very exciting times from what we heard in the morning till the fireside chat. So it's time to demystify what is a digital twin, and then I'll come to the sustainability question a bit later. So what digital twin means, let's keep the technical jargons aside. Now, what exactly does it mean? So it is basically three things. The first is that you have a physical twin, which is a 3D beam model, LOD 400, LOD 500. LOD is the level of development, level of detailing that you have. So, and also marrying the asset register. Just think of a building. So there are so many assets. So marrying the asset register into this 3D beam with locations. So this is basically the physical part. The second part which the digital twin does is the service twin. So what exactly happens? So if you do Kobe, I'm just naming a software. So with a app, you can actually see what is the warranty, what is the SOP for maintaining it, what is the breakdown history. So this gives you a lot of transparency on how the equipment is maintained, both from the maintenance point of view, the cost productivity point of view, as well as from the sustainability point of view. And the third is the IoTs and the platform. What we heard from the morning, I think the platform part is something which is the IBM's Maximo or Autodesk Tandem or iTwin. So this is one part where the technology has come at par. IoT devices also has come up at par. And this is called the data twin. So there is a huge amount of data which is being thrown where you can use advanced analytics. The sustainability actually is transparent. When you say I'm a net zero building, is it transparent? And why it needs to be transparent? For the sustainability manager in the company, for the city planner, for the company planner, for the public at large. I love my city. And when we say that this is a net zero building, net zero airport, does it really mean that? So, and I'll give you a small example, both from US and as well as airport in the city that you love. So both of them try to make a digital twin. So when and they say that their net zero journey is dependent on the digital twin. So what they're saying that, okay, we have a lot of renewable energy sources to power our facility. But beyond that, is our equipment also doing the maximum productivity, the maximum sustainability as the OEM or the original equipment manufacturer designed it? Are we using advanced analytics to understand how we can save on emissions? So these all actually give you, the digital twin actually gives you the platform to do this. Have I answered the question?
Very, very effectively. But that's a good example from America. Waleed, is there anything that you can talk about closer to home?
Yeah, you touched on a very hot topic, actually. Basically, energy and sustainability aspects of built environment is becoming hot and hotter every single day. What I think we are lacking in the digital twin technology is that we don't, I will touch base on this on several points. So the first point is related to embodied carbon. So, for each and every building that we build, there are materials that are being extracted from sites all over the world, gets transported to our to the place of construction, and then the construction activities starts. So this kind of activity consumes energy, it consumes water, it emits carbon. So we have tools to estimate the carbon emissions related to these activities, but we don't have the tools to monitor this on site. We've been struggling with this on, with our clients actually for the past year or two, trying to develop even ourselves softwares and tools that will enable us monitor carbon emissions during construction. We don't have this at the moment. I was speaking to one of the platform developers this morning. They mentioned that we are facilitators, we are integrators. We can integrate with some other platforms, but we really don't have the capability to monitor material and approve, and the approval process of these kind of materials, whether it passes the certain criteria for carbon emissions or not. We know we have one-click LCA, for example, for embodied carbon, but we don't have something to monitor this kind of activities on construction, from construction point of view. Now, looking at the second point of it, which is design aspect of built environment. We know that we are using energy models that are being developed since the beginning of the projects, from concept stage, schematic stage, detailed design stage. But in most of the cases, it stopped at design stage. It never goes and continue to reflect on the developments that happen during construction stage. We don't have actually calibrated models to reflect on procured material and actual equipment performance. We don't have models that move on forward to the operational phase where you have sensors and you have data that needs to be analyzed. So from what I'm looking at is that it should be an integrated process across disciplinary act, not only by designers, but contractor and facility management should be there from day one also. We've been doing some work for one of our clients in the region where they asked us for a design and build contract that would dictate a performance criteria on energy and water for the building. So whatever the designer has to design, and he doesn't need to just throw it to the contractor for him to do whatever he wants to do with it. He has to commit on the performance. He has to collaborate with facility management and the contractor to achieve a certain criteria towards achieving this performance criteria, which will stay with them for the next 20 years. If they don't actually perform well, they are going to be penalized for not achieving these performance targets. So we really need to bridge the gap between the design models, design energy models, and the in-use models. So we have to develop and calibrate energy models to the next grade, to update these to reflect actual data from the operational point of view. And then we will have the capability to really look at something we call digital twin, to have a model that really reflects what really is there for the design and for what is actually there as assets and what is being really monitored on the operational side. So then you have an energy use intensity 1, energy use intensity 2, then you can compare between these two. And this is where you can see the gaps of where to improve and which end users you are facing the difficulties with. Is it lighting? Is it HVAC? Is it a building envelope? What is it exactly? This is how you can tackle this. You can have a business case developed based on actual data that you have for your models.
Just to add to it, we moved around here, the property developers, the asset managers. We see a huge interest from the facility managers to add to the sustainability landscape of the country, of the city, of the company. And I think digital twin is something with the energy modeling is something which empowers them to do that. I mean, it is ultimately small activities which add to that, right? And so digital twin actually empowers them, and we find a huge interest. The question obviously is fast and economic implementation, But I think the technology is there to really achieve that.
Right, the technology is there. However, we are struggling with finding skilled people who can use this technology. We understand that we have data scientists and data analysts. All due respect to what they are doing an amazing job. But nobody can understand really what needs to be done in our industry better than our own industry practitioners. They have to step up and start dealing with data more. They have to understand data. For example, during concept stage of a design, we have to really build our energy models and thermal models. What is the best orientation? Can we do several scenarios? We do parametric analysis. Many of the architects now are stepping up. Now we need more of a better understanding. We don't need energy modelers only. We need energy modelers who understand data. They need to understand what they are inputting in these models. They need to understand what the outputs are. They need to analyze the outputs. Does it make sense? Does it make sense that my office building consumes 600 energy kilowatt hour per square meter per year, while the norm should be around 200? If, as we say, garbage in, garbage out. So we really need to have practitioners who really understand data and analyze data. This is from a design point of view. Now, from facility management point of view, we have BMS systems that are available for, like, any building that was built in the past 20 years have a BMS system that is either not being used or being used as a monitoring tool only, or inactive, or maybe it's an empty room with a signboard called BMS. We really have to tackle this. We really have to use BMS to what's intended to be. We need it not to be as a monitoring tool rather than a control tool for our buildings. And we also need skilled facility management practitioners who really understand what each curve that this BMS is producing. We have to educate them, and maybe it's now, as Mr. Ahmed Balawi mentioned before, it's an individual effort at the moment by people who wanted to learn about data in our practices, but we need to have initiatives internally in these companies and the facility management teams to better understand energy and water consumptions, trends for equipment, for material, and to try to visualize this data and analyze it, and what are the actions required to resolve day-to-day struggles that they are having within the assets that they are running.
So I'm going to pick up on the word skills there. You're talking about upskilling. Certainly, we live in a sort of ChatGPT future. That's the narrative, that's the meta-narrative at the moment. Certainly, AI and machine learning, surely that can assist in terms of predictive maintenance and that side of things. Surely that's going to have more of a role than skills.
Right. I believe the skill set needed for this kind of, at the moment, is much simpler than AI and automation. AI and automation is making our life easier. However, we have platforms that provide courses like EDX, Udemy, Coursera. All of these have free courses that you can take and learn about data and analyzing data for construction activities and for the built environment activities, that you can utilize this data in your day-to-day tasks. You have the opportunity, you have free knowledge available. You just have to have the attitude and the courage to enter that field. I know, I understand that this is not what we learn in the university. None of what we are doing in our daily life is what we learned in university. The university degree is a ticket for you to enter the market. And then you develop your skills. And you will keep developing your skills moving forward while you are throughout your life and your career. And this is why continuous learning for built environment people, whether they are designers, contractors, and facility management, they have to really step up and do their extra curriculum activities.
Yeah, so I just cut you off there.
No, in fact, I was building upon what Walid was saying. Yeah, I mean, we heard also from Tawfiq that AI is here to support, not to replace, which is an important takeaway from one of the sessions we attended today. This will help us to reduce, the energy and carbon emission. AI and automation will be there to help us reduce. But aside from reducing the consumption, there are other 3 tactics that will help facility managers to step up for the decarbonized future. One of these tactics is replacement of energy sources, right? So we have been talking about renewables for decades now. Probably this is the first thing comes to mind when we talk about sustainability in buildings. Okay, so people would think, yeah, I will install rooftop solar, and then my building is sustainable. In fact, it's not the full answer for this challenge. So reducing with automation and AI is one of the answer. Replacement of energy sources is another part of the equation. And also electrifying the equipment is one of the very important tactics that we have to look into when we operate a building that should be decarbonized for the future. Electrification in one form comes with the introduction of electric vehicles to our buildings, which makes our buildings that exist today the potential gas stations of the future. So we have to rethink about how this building will operate in a very unusual environment of energy, so with the introduction of electric vehicles to our buildings, and also rethinking about how we electrify cooking equipment in residential buildings, for example, how we electrify some heating equipment with heat pumps. So electrification is also one of the very important tactics we need to look into. Science has proven to us that digital and electricity are the recipe for this future because, in fact, digital is the enabler for efficiency. With digital, you make the invisible visible. You optimize, you improve. And electricity is the greenest source of energy. So once you electrify the asset, you are able to decarbonize it. You are able to supply this electricity from very efficient and very green sources. So for me, reduction, electrification, and replacement are very important. Then there will always be some carbon that you can eliminate where offsetting would play a part here, but we tend to minimize this part. Very
interesting. Now, in terms of we're talking about new built assets predominantly. In terms of the existing built assets that we have, has anyone got any strong thoughts here about retrofitting and the direction that we need to move in terms of that?
Right. So for the facility management and for operational phase of buildings, it's really important to make sure that we have what we call an asset list. Now, this asset list can be developed through many ways. I would mention if it's already an existing building that has been running for the past 50 years, most probably we don't have drawings, we don't have energy models for that. We can do 3D scanning for all of these assets. We can start doing this exercise all over from the beginning to allocate, to gather all this information and then to understand how these assets are behaving. Number 2, which is for any building that has been built recently, which basically have some drawings or have an energy model or have basically an asset list, having a BMS system. So BMS is a very important tool that we gather data about, and we have a strong library of information that we can get about each and every asset. Now, what really the FM team can do is basically having the energy in the center of the maintenance practice. One of the inspiring books about this is what our industry colleague, Mr. Fadi Shakhshir, have a book called Energy-Centered Maintenance. So energy-centered maintenance have to be something that every facility management, I would recommend it for every facility management practitioner to read, because it gives you an insight on how to address maintenance for these kind of assets from energy point of view. I don't need only to replace the filter each 3 months, as the book says. I need to also look at the data, how much my AHU is consuming in this specific time. Is there any spike in the consumption? If there is a spike in the consumption, I would need to look at these filters. Maybe they are blocked before time. Maybe I don't need to wait for 3 months to fix it. I need to look at this after 1.5 months from now. So this is how I reduce energy, and I will do my maintenance as well. So this is one of the things that every facility management should be looking at. Now, looking at also retrofits. Now, and the importance of data for retrofits. Facility management teams can utilize BMS data and collect the data from these kind of assets to really build a business case, to show that we really need to do this kind of retrofit. This asset or this AHU is consuming this amount of energy. and we have to replace it. If we replaced it by option 1 or 2 or 3, we will save this amount of energy, and accordingly, we understand that this could cost a certain amount of dirhams. However, this would have a return on investment of 2 to 5 years, which is something logical that we need to look at and we need to understand. This is something that you can help you to do your business case for any energy retrofit that you would like to have. So energy and facility management goes hand in hand. I understand that many facility management teams are building the capability for their teams to look into the energy point of view of things. However, also they need to look at data from a data point of view as well, and Innova is doing something massive about this, from their monitoring and the data hub that they have for monitoring of their assets. Every client should have kind of systems to monitor their systems. Entertainment industry is key. Hospitality industry is key to analyze their data and to improve their systems, aided with proof evidences that we are reducing energy and we are improving our systems, we are doing our maintenance, and everyone is happy. Yeah.
Fascinating.
Yeah, I think I would second with what Walid and Yasser mentioned, because we spoke about the AI and also how the systems can talk to each other, right? Just to put into the tech terms, the EMS and BMS has to talk to each other, and then on top of it, there has to be IoTs and sensors, which has to talk to EMS and BMS, and then on top of it, we have to have a layer of data and analytics, which is like 3 different, if you segment into augmentation, it is 3 different layers. And to put into very layman terms, we had our personal experience in terms of, for example, let's say in 2014-15, when we were like 3,000, 4,000 employees, and then in a matter of time, we shifted to like 8,000, 9,000 employees. And then we had one single campus where we hired a lot of people. So there was an airflow issue wherein AC maintenance and this and that. But to be honest, we were able to fix this by splitting into multiple layers. And after that, in 2020, we all know what happened. So all of a sudden, with the toggle of a button, we had to work from home in one single night. So in terms of energy efficiency, maintenance, planning, and everything, just because we were all ready with the entire back-end effect, we were able to do everything. And you spoke about scaling up in terms of AI and everything, but I think we have to take a step. We have to think about scaling down as well. What will happen? If we keep on improving the things, we're going to scale up a lot. But what happens if you're going to scale down in terms of employees or in terms of the other energies and efficiency and everything? I think that the software plays a major part of that.
And just to add to Debashiz's point, I think when you're retrofitting buildings, it's really important because usually traditional buildings are built in siloed stacks that are vertical in nature. What he's mentioning is something that's horizontal. So basically you have the device layer, you have your network layer, and then you have an independent data layer that is really important for every sort of building because that data layer should be agnostic. It sort of provides functionality with the devices below, but also allows for ease of onboarding for applications at the top.
Absolutely.
Which traditional buildings right now do not have. It's really hard to onboard an application onto the BMS and get the right data. An example is fall detection diagnostics. It's almost impossible to do that without them sort of data modeling the layer themselves.
True.
So,
and what the magic happened is when everything is talking to when the software talks to each other,
right.
And then finally we get to see the data, and then we can analyze and augment the rest of the things. I think that's where the magic is.
Yeah, that's a very, very important point because, sometimes during an existing building operations and we wanted to improve the efficiency, we look at, do we really need to add more sensors? Do we really need to add more thermostats, more occupancy sensors, more presence sensors? No, it's not the case. We have a treasure called Wi-Fi networks that we have available within our buildings that will give us insights about the occupancy patterns, which we can really use to turn on and off simply the equipment that we have. If the Wi-Fi data access points represent, for example, a sensor, it's like how many people are connected to a Wi-Fi in a single room would tell you how busy this room is, and accordingly, you will be able to increase or decrease the AC for this room or turn off the lights, right? So this kind of integration between the IT systems as well as the building control systems have to take place at some point, and the digitization and you can say industry level monitoring is stepping slowly into the built environment market. So what we are seeing from years being developed for industrial assets in terms of valves, monitoring systems, motors, fans, all these heavy duty industries are being monitored. Their energy is being monitored, their water consumption is being monitored, their fuel consumption is being monitored, and all of that is monitored. Now, I believe this is the upcoming era for the built environment to have the same done for the building assets. This will help a lot in terms of monitoring as well as improving.
So sorry to interrupt, John. Would you perhaps like to open questions to the audience at this point?
Yes, certainly. So I think we've got 5 minutes or so.
Absolutely, yeah.
Are there any questions from the audience?
That magic phrase again, 3 questions. I'm sure there must be more than 3 questions, though. Take 3 questions. Any questions, please? Gentleman right at the back there. Thank you for getting the microphone there. Just there. Thank you.
Good afternoon. I'm Mohammad Mursaleen, transportation planner. I've been working with intelligent transport systems for the last 25 years in Japan. My question is about when we talk about digital twin, there are different levels of the concept itself. If we are trying to make a digital twin of a tool, machine tool, the level is different. We are talking to materials. We are working on materials only. And when we are talking about digital twin of a building, it is again material plus the stakeholders, which are the user. And the user is a human being whose behavior is highly random. And when we go on a little a step ahead, and we talk about a digital twin city, it is an integrated system with buildings, with transportation system, with human beings. So, the real benefit of having a digital twin is in the last, and that's what we are doing. We are just trying to create an integrated environment where energy loss is minimum. That is the idea. So how will we integrate all these phases into one integrated system if it is applied on an environment?
Yeah, I mean, maybe I can. Maybe I understood your question, and it's related to, basically it's a joint effort. We all have, let's say, a role to play with regards to how we decarbonize the built environment. Now, to decarbonize built environment is going to be a joint effort between design teams. Client, first of all, should have the ambition, should have the attitude, should have the will to do that. Design teams have to be cooperative. Interdisciplinary act is very important at this stage. And facility management team and contractors needs to be ahead as early as possible in the process of designing any building. I believe that it's becoming more and more important, the approach of design and build for the construction environment. It's becoming very important to do design and build contracts, where contractors and facility management teams are hand in hand working with design teams as early as possible to develop energy models that will give insights on the form and the orientation and the glazing window to wall ratio and the envelope parameters and the HVAC systems options that we have, and the different fans, the different lighting systems that we can have, the landscape, the irrigation systems, the renewable energy offsets that we can do. So all of that has to be developed stage by stage, aided with energy models and I can say BIM models that are now taking place and aided with energy modeling capabilities such as what we have for Autodesk, we call it Autodesk Insight. This tool is part of, you can say, Revit, that you can run energy models at a very early stage from design, and then you can develop on that and add more details to reach LOD 200, 300, 400, 500. I know maybe 400 is the practice now, but 500 also has to be there. LOD 600 has to be there as well, because looking at the performance of buildings from day one will enable you to take the right decisions at the right time with everyone on the page. With you looking at this, and the decision is made once and for all, nobody will come back at a later design stage saying, this is a value engineering, we'll have to cut cost, let's go back to block one, right? So all of that has to develop hand in hand from day one to integrate the design models into construction calibrated models, into in-use energy models, I call them, which is like the operational energy models, or we can say it's a version of the digital twins that will see everything, will see the history of the whole project from day one of design until the last piece that has been purchased or procured. And then you can start really doing the operational activities of comparing your predicted models, calibrated models, with your actual energy and water consumption data, and then you can decide on which improvements needs to be done. So it's a whole life cycle approach for built environment. Digitalization is here to help built environment to decarbonize. I believe it will play a major role in decarbonization and into helping reducing the emissions and combat climate change.
Just to add to that, every innovation has actually fructified and come to people after a strong platform. So this is what the takeaway from here, that strong platforms have already come, the Autodesk Tandem or IBM Maximo or iTwin. So after that, see, once there's a platform to put all these disparate elements together in one platform, and then we have people like them, somebody wants it in mobile, somebody wants it in different platform. So this innovation has started, and that's the very important takeaway, I think, is from the panel and from these days' discussion on digital. The platforms have come.
Huge round of applause for our valued panel. Thank you very much indeed. Thank you.